And let's get started with the first talk of this room, after the keynote, by Ernesto Jimenez, Inception, Go programs that generate Go code. Thank you.
Thank you. So, is it on? Or is it muted? Let me check. Hear me? Okay. So, this talk is basically, it talks about like Go programs that generate Go code. And the things that I really like Go. Go is really simple. It's very powerful. The tooling is really great. The standard library is amazing. But for me, like coming from Ruby, there's one thing that like I didn't like really like fall in love with, which is like all the boilerplate that I felt like I had to be writing. Yeah. Sorry.
Let's try now.
Yeah. So all the boilerplate. By boilerplate, I mean like in Ruby, like there's tons of magic, so that you just like most of the code you're writing is your business logic and the things that you like the problem you're solving. But in Go, because like static typed and like strong type and all that stuff, like there's lots of like mechanical code that I felt I had to write. So basically, this talk is about my experience. And so I've been working in Slackline, and like all the message brokering we do that is in Go. I also maintain Testify, which Matt Ryer created, and that's like a testing package that is like the most popular in Go. It's used by many projects, and it's all about like with those kind of projects, like my experience I've had like reducing boilerplate and trying to avoid like writing all that mechanical, that obvious code, and focus on just writing like business logic and like code that is going to be valuable and that I enjoy writing. And how we are going to be reducing boilerplate by basically having Go programs that either parse data and generate Go code, some Go programs that modify Go code, or programs that parse Go code and generate like more Go code. So to start, like parsing structured data, parsing data to generate Go code, this basically you have some structured data, and you want to generate like some repetitive code out of that. So one example for that, for example, is Google has this API discovery service where like they define all their APIs in JSON. And then when you go to one of their libraries, like the Go standard library, all the code for all their APIs is actually like generated automatically. So if you go into this repo, apart from like having all the libraries from like all the services Google has, you can see there's a package where they are actually like generating the code for those packages, so they don't maintain them themselves. Like they have this program that will like read the JSON, and it will generate all the code. And you can see like they're like doing it like very manually, where like they're like printing the package import and like all the different imports they have and everything. And this will, like, when they run it, like, it will generate all the clients, because the JSON already has like, on the information of like all the endpoints, like the JSON schema from like all the requests, responses, and everything. Google is not the only one doing that. So another example is Heroku. Heroku, instead of like building their own, like creating their own JSON format, they tried to use JSON schema and JSON hyper schema. And instead of like having their own code inside the repository for like their code generation being related just for their project, what they did is like a standalone tool that is open source that is going to like read JSON schema, hyper schema, and you can do something like this, where it's like, hey, schematic, here's the JSON hyper schema for the Heroku platform, generate the client, and it's going to generate all the Go code for you. Another interesting difference with the Google one is that instead of like doing all that like print line by line, what they do is they use the text templates. So within the project, you can see they have like some templates that they use to generate the code, and basically what they're doing is like reading the JSON, parsing the JSON, understand the JSON, like building some structs with the information about like the API, and then running those templates on that information to generate all the code. And it's not only about like generating clients. Basically, like this is all about like any structured data that you have, like you can use to generate like all that boilerplate code. A good example is like if you have had to build a GitHub client, for example, they had like huge JSONs. And in Go, like you want to like parse that, so you need to create a struct, and you end up having like to type every single field from the struct that correlates with the JSON, including like the JSON attributes. So this program, for example, what it does is that you give it a JSON, and it gives you like the struct that you'll need to parse that JSON. And like then you can like put that into your code, and you don't need to build all that by hand. Which is interesting, like reduces the need to like build that all by yourself and do all that repetitive code yourself. So that's like using structured data and generating Go code. The next one is modifying Go code. And this basically one of the main things that makes the tooling in Go so good. So when we do Go FMT and we get code like this, and we run it and turn it into something like this, or when we have we use Go imports and we have code and you're using a package, and when you run it, you get the package automatically done. That's like a program that is going to be like reading your code, modifying it, and writing it back into this. There's plenty of those, like not only from the Go project itself, but also like different projects that people have been building, like Go returns. And as we said, it's like reading code, modifying the code, and replacing the code. And all of this is powered by the standard library. So when you're reading the code, Fatih did a great talk yesterday around this topic. So when reading the code, you can use Go build. And Go build, what it does is like a package in the standard library where you say, hey, give me information about like this package path. And then it's going to tell you, well, this package path is in this part of the disk. These are the different files that you have. These are the different test files. These are like the different dependencies and things like that. So you can gather information from a package. Then you can go and say, okay, so I have all these files that GoBuild told me about, so I can scan and parse those and read all that code. Then I'm going to modify the code, so Go has like the abstract syntax package, which when we are reading the code, this is what they're going to be generating, like it generates an abstract syntax tree that you can like go in and modify. And once you modify it, you need to replace it, and you have like the Go format and Go printer, which allows you to like take an abstract syntax tree and generates the actual Go code. So at the end of the day, when you want to like do that parse, like it's just like 4 steps, like read the code, generate the abstract syntax tree, modify the abstract syntax tree, and replace the code. And the only part, like the main part you need to focus on is modifying the abstract syntax tree, because all of the rest is provided by the standard library, which is very nice. And the thing that I'm most interested with like all this thing about code generation is like actually parsing Go code to generate Go code. And it's like you take code and you want to generate the boilerplate code. And like our code at the end of the day is just like a structured data. Probably not in Ruby, because like it's a structure, it has like a syntax, but it's like really, there can be like lots of magic, and it's not like easy to infer that from just the code. You need to evaluate the code in order to figure out what's going on, like what the different methods of each classes are, and all that stuff. But in Go, with the source code, you can get lots of information just from the source code. So for example, there are projects like IMPL, which like you tell them like, hey, I want like the skeleton for to implement that this interface, read closer, with this receiver, and it's going to like give you like the skeleton of like all the methods that you need to implement to like to satisfy that interface, and you can run this with like tools like Vimgo, so that you don't need to be like doing copying and pasting of the different methods from the interface and all that stuff. You can get all the boilerplate with the panics, and you just like fill in the blanks. And this basically, you like before, we read the code, get the abstract syntax tree, and like now instead of modifying it, what we're going to do is analyze it and generate the code. So that's like the one thing that I do a lot is generating mocks for my interface automatically. So in Testify, we have a mocks package where basically if you have like a downcaser interface, you can create your own mock and say like, okay, so when I receive the method, a call to the method downcase with the argument foo, I want to return foo and nil as the error, and like you call that on that method on the mock, and then you can assert like that you actually call that method, and like it allows you to build mocks. So when you're, it's really useful whenever you have a Slack that has like another dependency. So for example, for us in the Slackline, we have like all these WebSocket connections. We wanted to test the code that is like reading the data from the WebSocket connection. You don't want to be like opening WebSocket connections and implementing that protocol just for the testing. So we mock all the WebSocket, like receiving data from the WebSocket, and we test it that way. But with Testify, when you implement the mock, you had to do something like this. Like you have the mock downcaser, you are embedding the mock from Testify, and then you had to build something like this where like whenever you had to implement that actually like that downcase method and do these like weird calls inside the downcase method. And you had to do this with all the methods from the interface. And if you look at the interface and what you're implementing here, you already have like all this code, all this messy code. Like it's not doing anything fancy. Like all this that is doing is plumbing. It's like getting like some arguments that you know which arguments they are going to be from the interface, and returning some arguments which you know from the interface. So it's like, why can't you like? I'm sure somebody must have done something to do this for you. Did a quick search, and it turns out like Evan Phoenix had done Mockery, and with Mockery you can say, hey, Mockery, give me like a mock for this interface, and I just want to use it for testing. And Mockery automatically will create a file, and will have like all that, will generate all that code and all that plumbing for you. Once you start doing that, then it's like, okay, so how do you document like what people need to do in order to keep those mocks up to date? So when I add a new method to the interface, how do people in my team know what they have to run, what's the actual command they need to run in order to get that generated code updated? And the thing is that like the Go tool has this, apart from like Go build and Go test and Go get, one of the things that they have is Go generate. And what Go generate does is that it reads your source code and looks for these comments like this that start like with Go :generate. And what goes after that is a command that is going to be called on your system when you run Go generate. So now instead of like having to call like Mockery manually, what I'm going to do is like add this comment into my source code. So when I have like this project, like I do Go test, I don't have like the mock downcaser defined, or it doesn't satisfy the interface. When I run Go generate, it automatically generates the code, and then my test pass. So if I do any changes or anything like that, I run Go generate, and then that's going to generate all the code manually and run all the different commands that I use to like generate different parts of my code. And then again, this is just basically analyzing the abstract syntax tree and generating code from that analysis that we've done. The thing that, when I started using this, the thing that I came across is that there were actually some problems when using this. So for example, you'll have like an interface that embeds another interface, which means that to satisfy the interface, you need to like implement both the methods defined in this interface and the one that you embedded. And Mockery wouldn't generate the methods for like the embedded interface. It will generate just the methods from like the interface you told it. It wouldn't resolve all of that. So I created an issue, and even said like, well, this is a non-issue. The thing is that like it requires being able to like parse entire packages and like trying to figure out all those dependencies and like all those interfaces, and like when you are doing the embedding, I need to like figure out like this is the embedding, and I need to go like somewhere else, and where do I need to go to figure out like what that embedded interface, those methods, all that stuff. So it's really complex. And it was really complex because like they were using the Go AST, and the Go AST is like very raw data. It's just the syntax tree from like your syntax. It's not doing like any of that resolution or anything like that. luckily, like after he released the tool, since I think it was like Go 1.6, we have Go types also in the standard library. So if instead of like using Go abstractions, the Go AST package, you use the Go types, what Go types is going to provide you is Go types does all that analysis of the abstract syntax tree. It's going to like, get all the code, you're going to read it with like the parser and scanner, and then you're going to use Go types, and instead of like having to go through the tree and through the syntax and trying to realize all those details, Go types is going to do all that resolution, and it's going to say like, okay, so this interface is embedding another one from another package, so I'm going to have like to go read the source code from that package and like do all that work from the reading the code, analyzing the code. So all of a sudden, like you don't even like analyze the abstract syntax tree anymore. Like to generate a mock, you just need to like generate the code. Like you read the code, generate the abstract syntax tree, and analyze it with the standard library, and you just use Go types to like gather information about the types in the code and generate the code from that information. Which means that now we can like generate any mock. We can mock like packages from like our packages. We can mock packages from the standard library. We can mock like any composition of packages, and Go types is going to like do all that analysis for us. So I did an experiment like I tried to implement like mockery with Go types instead of like the abstract syntax tree, and it turned out that it was like less code. I also had less issues. And the code was like much simpler because like I no longer had to analyze all that syntax tree and like do all that nitty-gritty of like trying to resolve and analyze those things. Like the standard library does it for me. So now instead of like Go mockery, I do like Go generate automock, and I want a template to be testify for IO reader, and that generates the code for me. One important bit of like this is that look at the beginning. I say, hey, this code is generated by this tool. You should not be editing it by hand. I recommend whenever you are generating code, you put a comment like that, because otherwise you're going to have like somebody open a pull request, like changing the code that was generated like automatically and like trying to fix some stuff, which can be like lots of code, and when you tell them like, well, this code is actually generated, what you had to do is like change this template that it was much simpler instead of like changing like hundreds of lines of code, they're going to be angry. So when you get the comment, like there's still some people that are going to go and modify that code manually, but that's not your fault, it's their fault because they didn't read the comment. So they can no longer like yell at you. And another thing that I realized is like, well, we are using templates to generate all this code. So why don't we allow like you to configure what template you want to use? Like I like using Testify for the mocks. Like Matt, for example, he likes like using like some other syntax or some other package. So Go Automock like comes with like a couple of templates pre-embedded, but I allow you to specify another template. And I even allow you to say like, hey, give me the template for like for this type, so that like you have like the scaffold and you can like modify them, like how you want to generate the interfaces, and then like you use the file when you were doing like Go Automock template. So you no longer need to like use like my mocking library, or like you can generate any mock in any fashion that you want. And you don't even need to worry about like how are you going to like use Go types or anything like that. You just worry about like the modifying the template. Another place where I've done code generation is in Testify. And in Testify we have like this package that is called assert. And assert is basically a collection of like tens of helpers of different assertions. So you can say, hey, assert these two objects are equal. Or you can say, hey, assert that this code that I'm going to run within this function doesn't panic. Or assert that these two strings have equivalent JSON. All that stuff so that you don't need to be typing that over and over again in your tests. Basically in assert, like in the package, we have like two methods for each like assertion, because we allow you to say, hey, we allow you to call like assert.panic and give me the testing T and like the function that you want to run. Or you can also say like assert.new and you with this T, and like you get the assert object, and then you call like that panic on that object. So there's like two flavors to call the assertions. And like as we say, like the second one is just like calling the other one. So it's like for those tens of assertions, we have like then the same methods, the same assertions again as methods. But then we also have like a required package, which is basically the same as assert, and it actually calls assert, and it has like the same assertions, but like it does like things a bit different. So assert won't, the way it works right now, it doesn't stop executing the test when an assertion fails. Like required does stop executing the test. But then again, like what we are doing here is like, okay, so we have like assert required.panics, which calls assert.panics, and we have like in the assertions type, we have like the panics method too, which is calling the other one. So it's like we have like three boilerplate functions for each assertion that we have, which turns out to be like tens and tens of boilerplate functions that you need to write. And you'll get like somebody will contribute, like open a pull request, and they'll like add a new assertion, and maybe they'll add like one of those boilerplate methods, but because they don't know about the required package, like they wouldn't add those there. So we had to stay on top of like what people were contributing and how to make sure that the code actually had like, they were actually like, all these boilerplate methods were like properly coded, and like all the packages were consistent. So I said like, hey, why don't we try auto-generate it all that code? So instead of having to ask people to like create 3 boilerplate methods and keep those up to date whenever they do an assertion, let's generate those methods, those functions for us automatically. So we use like GoGenerate again, but because this code generation is very related to the project, instead of like calling an external tool like GoAutomock, what I do is like, hey, when I run GoGenerate, I want you to do GoRun, and I want you to like go to the like one package above. So if you are in testify/assert, you'll go to like testify _ codegen and run this like main.go. And I want to run this program with this template. And like we have like that 3 times, like one with each template. And templates are like this, are like 3, 4 lines of code depending on the assertion. And what that program is going to do is like, it's going to look at the code, it's going to look at all the functions for the assertions that we've got, and it's going to take the template and it's going to like render the template for each one of the assertions. So we use Go types, but we also use like GoDoc, because we need to know like what are all the functions that are defined in the package. So instead of like using the abstract syntax tree, for example, to like find all the functions, like you can use GoDoc and say like, hey, generate the documentation, the public documentation for that package. And now give me, let's take the list of functions that are like that exported and are documented. And with Go types, I can say like for each function that is exported, Go types, give me the object that correlates with this identifier, with this function name. Is it a function? Yeah, nice. Now, Go types, give me the first argument of that function. Is it a testing T? Yes. Well, that's an assertion. So now I'm going to run this template with this function. And it does everything automatically. And instead of like, I try as much as possible to reduce the amount of like tweaking of like the AST and the code types, and like if you can get some information from GoDoc, it's going to be simpler. It's going to get your code generation code simpler. Do that. So did that experiment, and it turned out like the code generation code was like 240 lines of code, and with that we actually removed like almost 850 lines of code. So we have removed like 850 lines of code that you had to manually type, that were like not providing any value because it was all boilerplate, and we just have like 240 lines that are like actual like code that is doing something interesting. And now whenever like somebody like contributes a new assertion, so I can just like run the GoGenerate, and that's going to generate the new code. I'll add that to the repository, commit it, and everything is there. No longer anybody has like to be manually typing those functions. And another experiment that I've been doing with the code generation is using packages like NetHTTP. It's common to have like this kind of pattern in some packages where you have like http.get, which actually under the hood is going to call like get on the default client. It's basically just like a convenient method, so that, like you have a default client, but like if you want to create your own client and call those methods manually, you can do it. But there's like a convenience way to do it with just functions, like exporting the functions that are just wrapping up the methods from a default. So I was looking at this, I was like, hey, why do I need to keep like all these like functions manually in sync with the actual object? So I would see packages that the function wouldn't align properly with the methods, or they will forget to add some of the functions and things like that. And that's because like they were like writing this code like this manually when they already have like all the information in their code, or like what are all the methods that are implemented by the default client. So what I actually want is like when you have like this default client and you do a new, I just want to implement the interface, and this part I want to generate automatically. So I did like a quick experiment, which is like go export default, and basically what I do is like, hey, here's my default client, and by the way, with using GoGenerate, like export all the default, like all the methods from like this default variable, this default client that I have, and I only need to write like all my methods, and all those functions, all those higher level functions are going to be generated manually. So when I run GoGenerate, it generates everything. And as always, please mention that the code is manually generated, or otherwise somebody's going to come in, edit it, and be angry with you when you tell them that that's actually automatically generated. Other thing that I learned with this kind of thing is that you are going to be doing, you're going to have to import packages for like the code that you're writing, and like some of the packages that you're going to be importing depend on like the actual methods, but some other and are going to be resolved based on like the methods that you're implementing. But other packages are going to be like packages you're using in your templates, and you need to import those. And what I've seen is that some people will like will add like those manually, and they'll try to run Go imports on the output of the generated code. And the thing with Go imports is that I try to always avoid it with the generated code, because if you forgot to add a dependency in your template, Go imports is going to try to fetch it. And the way Go imports work is like going to look for packages with the same name in your Go path, and the package that it finds, it might not be the one that you actually wanted to use. The typical example is like you are using a template and you want an HTML template, and Go imports like text template instead. Another example that I have is for generating decoders. So in Slackline, we have like thousands of WebSockets connections with Slack to like read all the messages, and like on all those connections, we get like JSON messages constantly. And we need to basically decode that JSON into a map of strings to interface, because we don't know the type of the JSON, and then we need to check at the type key in the JSON and create a struct based on the type. So is it a message, or is it an update on the user profile, or like what's that information? So I then want to do like all that, like checking the type and then like creating the struct manually. So I looked online, and like it turned out like HashiCorp had this program that does like map structure, which like it'll take like a map of like strings to interfaces and a struct, and like fill the struct so that you automatically from the map. The thing is that it uses reflection. And basically, the reflection package, what it's going to do is like whenever it's going to like do one of those decodes, it's like to move data from the map into the struct, it's going to whenever it needs to do that, it needs to like inspect the struct, look at what the fields are, and like we are doing that like thousands of times per second. Which it turned out like we were having some performance issues. So like we did some benchmarking, And we saw that like with a very simple benchmark, like in a very simple benchmark, like using map structure to convert like a map into like copy the data from a map into a struct was taking like 61 allocations for each operation. So it was like generating tons of garbage that we actually didn't need. So like when I saw that like all those allocations and like all that that pressure in the garbage collector, I was like, I wonder if like that's because of the reflection and how they're doing that. So what will happen if I was like manually writing all this code for like all the fields in my code, in my struct, would that be better or not? So benchmark that, it seemed like it was like less allocations, so did like a very quick project that is like Go and Marshall map, where you do like, hey, go and Marshall map the user, like get the code in this file, and when you run Go generate, you're going to get that file, and this, for example, has like 218 lines of code that is this kind of code constantly. That's like completely boring code that you don't want to be writing or reading or anything. So once you have that, you can do like, hey, user.Marshall map, and you give it a map. The difference between like doing reflection or doing that code generation is that when we benchmarked it, it's like we no longer were having like any allocations. And like instead of like doing like 9.5 microseconds per operation, we're like having like 179 nanoseconds. So like with zero extra pressure for the garbage collector because there's no more allocations. Then what happens if we change, like, if we add a field to the struct? My Marshall map method is no longer in sync with the actual structure from the struct. I will be getting the information in the map, but I won't be copying it into the struct. So one thing that came into our heads was like, hey, why don't we generate the test too? So the way this works is like it not only generates the unmarshaled map method, it also generates some tests that make sure that you are unmarshalling all the fields from the struct. So if you actually like add a new field to the struct, the tests are going to fail. And it's good to tell you, hey, the Marshall map is out of sync, run Go generate. And you'll run Go generate, and now your test pass because it's in sync. So that's like part of the whole like generating the code from the code. Like one other interesting thing that I've seen is if you try to go like deeper with this thing about like code generation, is doing domain-specific languages with Go. And if you're interested, like if you've done any Ruby, you really like DSLs. So for those who don't know what DSLs are, like you can look at Goa, which is basically a DSL for writing APIs in Go. And what you do is basically you have a package with a design file, and the design file is like really simple, and you are just saying like, okay, I'm going to define this API with this title, this description, this is the scope, this is the script, and this API is going to have like a resource that is operands with these actions, and like you are defining an API, and then when you do Go Agent Bootstrap for that package, and you look at your project, instead of having one file, you have like 17 files. And you have like a main file, which it's actually like setting up a server, an API server with like request IDs and error handlers and recording from panics and like logging. And you have like the controller with the action that you need to implement. And like you already have like the add function, and like it's telling you like, put your code here. So you just like write 2 lines of code. And now you have a server that is like serving that. And you have a client that is reading that. So like from that small like definition, it's like generating all the boilerplate of an API that you can like just tweak it and like have like a quick API, prototype it really easily. So how does Go do it? How do you go from this like simple definition into a full project? Magic? So it's basically, it's very simple when you actually look at it. It's more like Inception. So what they do is like, they take the design code. With the design code, they generate a temporary program. And with the temporary program, when they run it, is going to generate the actual code. So this is the temporary program, which is like a few lines of code. And the thing they do is that they're importing your package. So when they import your API definition, that's going to actually, like, when it's imported, it's automatically going to, like, fill in some variables in the DSL engine package. And that's going to be, when this program runs, it's going to generate the code. So wrapping up, you can reduce boilerplate. There are already tools that are going to allow you to reduce boilerplate and generate the mocks automatically and many other things. The standard library has, like, really good packages if you want to build your own. There are many open source packages that you can look at for inspiration in terms of, like, how they do things and to learn how to write all that code. Just remember, SKCD has, like, the knowledge for everything. Like, you need to balance, like, the work you're going to invest in generating some code versus, like, how often are you going to generate that code. So don't go crazy and spend, like, a week trying to generate, like, a file that you're going to generate only once. So any questions?
Thank you. If there are any questions, we have a bit of time. Okay.
Okay, thank you. I was very tempted to interrupt you with a question. I tried very much to resist until the end. So, it's very interesting. There are a lot of tools you explained, and it's quite easy. There was a talk also yesterday about how to build your own tools that generate good code. I have, if you want, a meta question. Did you look at how other languages solve the same problem? Because you mentioned several times Ruby, but of course there's not only Ruby. And I will also offer you, if you want, an answer, which is, this is exactly one of the problems that one very ancient language tried to solve a long time ago. I guess you can know, you can tell the answer, and the answer is Lisp, and it does that. And there is a good part, because it does this very generally, but there is also a bad part that basically you create your own language and the code becomes unreadable. So
like brackets everywhere. Like the first time
it's not the brackets, it's that it's your own language, because it's DSL everywhere. So if you want to move forward, my question is, how can you get the good parts of whatever was already solved, which is move, for example, the external tools into one general tool or inside the language itself, with avoiding the problems, the pitfalls that Lisp fell on, that was complete fragmentation?
I don't know how much, like, the things that the standard library already has the primitives for you to analyze all that code and do all that stuff. And then, like, what tools you want to build, like, it's up to you. Whether those tools will actually get integrated into, like, the Go project themselves, I doubt so. Like, maybe some tools, but, like, they're pretty hard in terms of, like, not accepting, trying to, like, limit the amount of things that they accept, because it's a strong commitment for backwards compatibility and, like, not breaking it in the future. If you want to, like, do this kind of stuff, like, my recommendation is, like, go find projects that do similar stuff to what you want to do. That's how I've learned to do all this stuff. Like Go types, the Go AST, like, they're, like, primitives, and, like, the documentation is, like, really cumbersome. So it's really helpful to, like, find a package that is, like, doing something very specific, that is somewhat similar to what you want to do, and read the source code and see what the methods they're using. And then you read the documentation for those methods. And you figure out, like, how to use those packages, like, that way. And that's the way, like, I find it really helpful. Like, and other languages, like, I've seen nothing similar with, like, Ruby at all. It's like, there's no, you can, like, read, like, a bunch of Ruby files and, like, figure out, like, what are the methods that are going to be defined in this object that I'm using here, because, like, you can do meta programming and, like, generate the methods on the fly. So there's no way to know that. So that's why, like, some languages have it easier than others. Like, some languages, like Lisp, like, are done to, like, do DSLs. Like, Go is not meant to, like, be writing all these DSLs, like, but you can do some stuff that is interesting.
Thank you very much.